All right, so how do we deal with a definite integral where we have limits of integration? Well, what we're going to do just like what we've done before. We're going to identify an inside function, right? I'm going to say, let's let u equal, now I see x squared minus 4 inside a power function. So I'm going to let u equal x squared minus 4, right? And then du is going to be 2x dx. Okay, now I can rewrite this as integral from 2 to 3 of x squared minus 4 cubed times x dx, right? I put the x with the dx. So that means over here I have to divide everything by 2. I'll get 1/2 du is equal to x dx. And then I can replace the x dx with 1/2 du. All right. Now, when we make this substitution, we have to replace all of the x's with u's. And we have to keep in mind here that these limits of integration are x values. This is x equals 2 and x equals 3. Okay? Those are x values. So what we're going to do is we're also going to translate those x values to u values using this substitution. We said u is equal to x squared minus 4. So if x is equal to 2, we can substitute that into x squared minus 4. We'll get 4, right? 2 squared is 4, minus 4 is 0. So that translates to u equals 0. Okay? I'm just plugging in x, the x values for the limits of integration, and I'm going to translate them to u values. All right, the upper limit is 3, and if I translate that to a u value, 3 squared is 9, 9 minus 4 is 5. Okay, so this x equals 3 corresponds with u equals 5. So now when I do my substitution, I'm going to replace the limits of integration with my new limits of integration. All right, I'm going to integrate from 0 to 5. I'm going to replace x squared minus 4 with u, so I'll end up with u cubed, and then times 1/2 du. Okay? That's the key. All right, so now everything is in terms of u, and the antiderivative here of u cubed is u to the 4th over 4, but then it's times 1/2. So I'm going to make it 1/8 u to the 4th. And then I'm going to evaluate it from 0 to 5, right? Because these are u values. I don't need to go back to x, right? If I've translated my x limits of integration to u, I don't need to go back and rewrite this in terms of x. So that's pretty sweet. Let's just do this. So now we're going to use the fundamental theorem of calculus, and we're going to evaluate this antiderivative at u equals 5, and then subtract the value at u equals 0, right? And that's going to be it. So, all right, so I have 1/8 times 5 to the 4th. Now 5 to the 4th is 25 times 25, which I happen to know is 625. And then we're going to divide that by 8. So, and then the other term here is 0, because we're taking 0 to the 4th times 1/8. All right. There we go. That's our answer, 625 over 8. Now that is the same thing you would get if you translated this, if you took your antiderivative and then rewrote it in terms of x and kept your x limits of integration. You would end up with the same thing, but it's easier just to translate the limits of integration into u values and then evaluate your antiderivative in terms of u. All right, so now in this last box, there's a little bit of let's see, this kind of summarizes what we did, but I think it's actually easier to understand it when you see an example. So essentially what we're doing is we're doing the substitution, but then we're also translating the limits of integration into u values instead of the original x values. All right, that's all I've got for this section, and I will see you in class.